Moving on. Interestingly, when I first looked at the list in the program, I saw the Euphonia, and I wasn't sure what that was, so I had to go and Google it. So when I Googled it and came back to the program, I then realised that it was a Google presentation, and this is by Julia Cattiau, and talking about Euphonia. So thank you.
Hi, everyone. My name is Julie. I'm a product manager in Google Research. And today, Lisie and I are going to tell you about Project Euphonia. So just to get started, I thought it might be helpful to explain what we mean by machine learning. So first thing first, what do we mean by algorithm? You can think of an algorithm as almost like a recipe that describes the steps that are needed for a computer to solve a given problem or reach a specific goal. Up until recently, all the algorithm or computer programs were written using explicit rules. To give you an example, in order to detect spammy emails, we were looking for very specific words that are commonly found in spammy emails. The way machine learn based algorithms are different is because they automatically learn the rules from data, as opposed to programmers having to explicitly tell those rules. So to go back to the example of the spammy emails, for example, email spam can be detected by looking at a lot of examples of spam flagged by users. This is more effective because if people who write those spammy emails change the words, the keywords in the emails, it will still work. In order to train a machine learning algorithm, we basically need to show it a lot of labeled examples. In this little example, we're trying to teach a machine learning algorithm to distinguish photos of cats from photos of dogs. For that, we essentially need a little group of photographs from cats and dogs, and each of them will be labeled with the word cat or dog. So this is what we call training. And then once the model is trained, we can do what we call inference. So inference is when the model is being used to recognize something. In this case, it can recognize a picture of a cat from a picture of a dog. So yeah, this picture is much more ambiguous compared to the examples we saw earlier. And you can basically use the model that has been previously trained to try to detect what is on the picture. If it's correct, great. If not, you can use this as additional data to improve the performance of the model. So as we just discussed, machine learning algorithms can be used to detect little cats on pictures or bunnies and even tell cats from bunnies. But what about blueberry muffins from dogs? Of course, that's a joke, but actually there's truth in this, because if you think from the perspective of the machine learning algorithms that we're training, if all you've seen are pictures of little dogs, you might get very confused the first time you see a picture of a blueberry muffins, because it looks a lot like a chihuahua. So the idea here is that one way to make a model more robust is to show it examples of things that can be confusing. In this case, if you add a label to those muffin photos, the model will become better at distinguishing little dogs from muffins. Now I just wanted to share a couple of examples of applications of machine learning technology that were developed at Google. So this first example is the Google Translate mobile app. What you can see on this animation is a feature that essentially detects text on a picture, turn this picture into written text, and then translate it in whatever language you want. So there are several machine learning models running one after the other to enable this functionality. And everything happens on the device so that you can take it on your travels and translate in real time whatever is around you. Another interesting application of machine learning is the Smart Compose feature in Gmail. This allows you to basically get some suggestions of how to respond to emails. It can save quite a bit of time, especially for short emails. And now, how can these machine learning algorithms that we just talked about be helpful for people who have ALS? So the same technology I just told you about is used to train automatic speech recognition algorithms. Um, and those models use millions of examples of speech samples from people reading things, basically, in order to work. In a nutshell, the speech recognition technology works as follows. We take the raw audio data, turn it into a visual representation of the sound, also known as spectrogram image, and then we use those pictures together with the labels, and the label is essentially the transcription of what is being said in the raw audio, and train a machine learning model to recognize those spectrograms and map them to words. This is how real-time transcription works, and it uses millions of examples of speech samples. Speech recognition is the technology that is used in assistive tools like the Google Home or the Google Assistant. And it can also be used to transcribe speech in real time to help people communicate. The question that we asked ourselves in our team is, could we make this speech recognition technology work better for people who have impaired speech? And the answer is yes, if we have speech samples to learn from. A couple years ago, we partnered up with ALS-TDI, which is a nonprofit organization in Boston looking for a cure to ALS, to collect speech samples from people with ALS. The idea was, if we want speech recognition algorithms to work for people who have ALS or other kinds of neurologic conditions that can impact the way someone speaks, we need examples of how these people sound like. So what we've been asking our participants is to read a series of phrases that we prepared with ALS-TDI. And then we train speech recognition algorithm to get better and better by using those examples. As of today, a little over 1,000 people have participated in our data collection program and have recorded over 1,000 hours of speech samples. Not only people with ALS, but also people with Down syndrome, Parkinson's disease, cerebral palsy. In addition to recording speech samples with the help of our partners and our participants and training speech recognition technology to better understand people with impaired speech, we also work with individual trusted testers to help us develop early stage prototypes. So I'm going to play a very short video to show you what our prototype looks like. And on this video, we're testing it with someone who has ALS and has recorded several thousand phrases for the program. And so she has a fully personalized speech model that understands her. So I will now play the video. So Andrea, what are you going to do for Christmas?
For Christmas, we are going to Philadelphia, where my in-laws live, and my parents will be coming with us.
Sounds good. Is it cold in Philadelphia in December?
It's always cold, and I sit on the couch in front of the fire for 5 days.
So what you could see on this video is our prototype application essentially transcribing in real time what she says. And again, the machine learning model that is powering this app is fully personalized for her based on the speech samples that she has recorded. So ultimately, our goal is to make sure that voice-enabled technology is accessible to people who have ALS and also and other types of speech impairments as well. We also hope that this type of technology in the future can help people communicate more efficiently. And now Lisie, it will tell you how the same type of technology can help people who cannot speak anymore.
Sure. So, right. So the question is for people who can't speak, what can machine learning do for them? So we can use machine learning to recognize facial expressions and then use that signal to trigger a preset action like speaking a phrase or sending a message. So you can see in the animation here that when the man smiles, the phone is responding. It detects that he's smiling and then responds. So this is the kind of concept that we are developing in our research. Next. And one thing that we really like about this concept is that it actually will enable people in this condition to react in the moment. So I know that it can be very challenging with like an eye gaze device or another communication device to kind of pick out each letter. A lot of times communication can be really, really slow. But by detecting the facial expression to activate something that's preset, that enables more spontaneous type of communication. And so in this video, you'll see one of our testers using his face gesture to activate a cheering sound while he's watching a sports game. So you saw that he opens his mouth and it plays the cheering sound. And so with that, if you'd like to get in touch or learn more, visit our website, g.co/Euphonia.
Thank you so much for listening. And if you have any questions for us, we'll be happy to answer. Thank you for listening.
So thank you so much. That was a fantastic presentation. And I think Lisie and Julie will be here to answer some questions. I'll just have a look and see. People be able to provide additional personalized training for the data sets?
Hi, everyone. Can you hear me?
Yeah, so they're just asking if there's additional personalized training for the data sets for their VUSs. I'm gonna have to put my glasses on for this. Oh, VUIs. I'm not quite sure what that stands for. Maybe they can kind of elaborate. Erin, if you could just tell me what that meant, I can. Yeah, and it's they're just saying they love the project, very exciting, wonderful presentation, really amazing information. Sorry, voice user interfaces. So are there is there additional training to be able to use the voice interfaces, the voice user interfaces?
Yeah, okay. So I hope I understand the question. Let me try to answer. So all the work we're doing is at the research stage. So we work with only a small group of individuals so far to record a number of phrases, and then we essentially provide them with personalized speech models that they can try at home. Of course, eventually we're hoping that this can be more broadly available, but we're still at the stage of research where a few people are working directly with us. Anyone who records phrases for the Euphonia project can then request this data and download it on their computer in case they want to use it for other purposes. So maybe that's what the question was about, and that's definitely an option. And we also compensate participants for the time they spend recording phrases for the project.
Yeah, I
hope
think to
that
answer the
answers
question, to address the question in the chat a little bit more directly, yes, we still are collecting speech samples for people who want to record for this project. They can go to g.co/Euphonia.
Fantastic. And Amy is asking if you do or could you collaborate with the voice banking services to collect further samples?
Yeah, that's a great question. We have actually been collaborating with some groups, for example, with John Costello and My Message Banking. The small difference is that the speech samples that we record for Project Euphonia are actually recordings from people who already have a speech that has been impacted by ALS, for example, so that we can then have examples of what someone sounds like when they have this type of condition. So we can in turn teach basically computers to do a better job at understanding this type of speech. I think message banking has a lot of data from how people sound before maybe their speech was affected, although I know that's not always possible. So I think it's slightly different, but in some instances with some of our participants, we have been able to use their voice banking samples. So yeah, definitely a good question.
Thank you. And Peggy asks, can the speech model change over time as the speech changes without the need for retraining?
Oh yeah, that's a that's a $1 million question. Actually, it's more complicated than that, but that's something we're well aware of, especially for people who have ALS, whom speech evolves with time. So currently, the models that we build work well if you still sound the way you did when you recorded the phrases, and if the speech evolves, their performance decreases. So it's an active research project for us to figure out how do we continue to provide useful technology for people how as their speech evolves. And that's a question that we're studying, but we haven't solved yet. Yeah, so that's a good point, and this is why also this is a research problem. We're trying to figure this out.
Oh, that's absolutely fascinating. And Bria asks that she realizes that this is for patients for ALS, but could it also be used for patients who've had a stroke?
Mm-hmm. Yeah, absolutely. And actually, I think we mentioned at some point in the presentation that we've had about 1,000 people providing speech samples for the project. And actually, those people have a variety of conditions from ALS. We've worked with the Down syndrome community, people with stroke, Parkinson's disease, cerebral palsy. So actually, the same technology can be applied to really anyone who has speech that has changed due to a condition and for whom speech recognition doesn't work very well today. And again, we're at the research phase, so we actually welcome speech contributions from anyone. We have a website, g.co/Euphonia, and anybody above 18 who has a speech impairment can contribute to the data set and get a compensation. And it is not only ALS, it goes beyond. But we did start, though, with this partnership with ALS TDI, which basically sparked the idea for the whole project. So we did start with a lot of people who have ALS, and many of our trusted testers have ALS. But actually, you're right that the technology is applicable for many other conditions as well. Yeah.
Fantastic, thank you. And Ahmed says that this is a great potential for making environmental controls much more accessible and cheaper using readily available voice control smart tech. So
Yeah.
And Emma Cochrane asks, how many phrases would participants need to record to participate?
Yeah, a great question. So when you sign up on the website, the first set of phrases that we ask people to read is 300. They're pretty short phrases, you know, think, for example, turn on the lights or set a timer, because this kind of simple questions belong to the vocabulary of smart speakers. I think somebody was making the point about environmental control. So that's definitely a very important application for this technology. So we want to have recordings that are relevant to that use case. So it's 300 short phrases. And for people who want to do more, we have other tasks that are longer, but it's only if people are, you know, have sufficient, you know, time and are willing to and able to spend more time. But the minimum is the first set of 300 to participate.
Fantastic, thank you. And Keith Miller asks, can this system read American Sign Language?
No, actually. That's a good question, though, and I think it's a very interesting problem. And I think with similar technology, you could imagine trying to detect sign language. We, though, in our team, actually, maybe Lisie, what you're doing could be closer to that. But on our end, we're looking into speech recognition, and for the sign language, the specialty is more image detection and recognition. And so actually our team is not directly looking into that problem, but it's something that would be extremely interesting to work on. I agree. We're not working on it right now, but I know of some startups and company who have spent some time thinking about that.
Absolutely.
Yeah, the project that I work on is looking at gestures, but they're face gestures generally, not hand gestures or signs at this point.
No, and there's an awful lot of chat here is just saying how excited people are about the technology and how amazing it is. And in the meantime, they can type it in. They like the they love the broadcast function, and the face gesture system is similar to Smile Mouse. Is that?
I am familiar with Smile Mouse. The system that we're working on, we're not using it as a mouse, but some of the face gestures that are used in Smile Mouse, I totally see the similarity there, certainly.
No, and what I really liked about your presentation was the joy on the lady's face when she was speaking and it was actually printing, because I know the frustration when people are using kind of voice recognition packages which actually just don't understand, and they have to keep going back and re-saying the word, and how frustrating it is. And the joy to be able to actually speak into the computer and for it to understand is just absolutely wonderful. So thank you for that. I just one more moment and just see if there are any more questions. I think, as I say, most of them are comments, are very excited comments in the chat. But I think that might be that for the moment. But thank you so much for your presentation. It's absolutely fabulous. Thank you.
Thank you for having us.